Good afternoon to all. In today's class, we will discuss the first life cycle of the thread. It is very, very important for exam point of view and to understand the concept of thread. So this diagram is very, very important. So explain the life cycle of thread means you have to draw the diagram first. After that, explain this diagram with these points. Okay. After that, next we will write the program on using runnable interface. Okay. First, I will explain life cycle of a thread. Very, very important. Listen carefully. So here in this diagram, we have 4 states. These circles are nothing but states. So how many states are there in the life cycle of a thread? There are 4 states. And the names of the states. This is new or born state. Next, this is ready or runnable state. This is running state. And this is dead state. So here we have 4 states. Okay. Now I will explain the life cycle of the thread with respect to these 4 states. Okay. Next, here what I have written, my thread T is equal to new my thread. Morning I explained one program now. In that my thread class, my thread extends thread. Means my thread is the subclass and thread is the superclass. So I am creating the object for subclass to access the members of both subclass and superclass. Okay, consider the morning program. So in that I have created one class, that is class my thread extends thread. Okay, that is nothing but defining a thread. Okay, now here I am creating the object for the subclass my thread. That is my thread T is equal to new my thread. This is constructor. Okay. Now this is the object creation of the subclass my thread. Okay. Now I will explain. Okay, these points with respect to these 4 states. Now first point 1. Whenever we are creating a thread object, means this is the thread object. So whenever we are creating a thread object, then the thread is set to be a new state or born state. So creation of an object for the thread is nothing but, okay, it is in the, now the thread is in the new or born state. Okay, so already morning I explained, no, class my thread extends thread is nothing but a thread. Okay, whenever you write class my thread extends thread, okay, and you write the class definition, that is nothing but definition of a new thread. And after that you create and we will create an object for that class my thread, no. So whenever you create an object for a thread, okay, then now the thread is in the new or born state. That is the first point. Whenever we are creating a thread class object, okay, then the thread is said to be in the born state or new state. Next, once we call start method, then the thread entered into the ready state or runnable state. Morning I explained, no, 3 points. What are the 3 points? How do we define a thread? Next, how do we instantiate a thread? And how do we start a thread? These 3 points are very, very important. Is it the second point? Yes. After defining the thread, using class thread extends my class my thread extends thread, we will create an object for that, no. This is nothing but instantiation of a thread. Creation of an object is nothing but creation of or instantiation of a thread. So here, so whenever you create a thread, first thread is in the born state. After that, what is the third point? Third point is how do we start a thread, no? So how do we start the thread? Using T dot start. This is the start method of the thread class. It is responsible to register our new thread with the thread scheduler and also invokes the run method of the thread class. So whenever you write T dot start, okay, so once we call start method, then the thread entered into ready or runnable state. So whenever you invoke this statement or whenever you execute this statement T dot start, so now that previously the thread was in the born state, no. So whenever you execute T dot start statement, At that time, the thread from born state, it will go to the ready or runnable state. That is the second point. Whenever we invoke start method of the thread class using T, at that time, our thread, okay, will go to ready or runnable state from the new or born state. So when the thread goes to the ready or runnable state from born state is after execution of T dot start method. Now we are in this state. Means now our thread is in this state after execution of T dot start statement. So what is this state? Already in operating system, waiting queue, like that here this is called waiting queue. Here you can draw one queue. All the threads are there in the waiting queue. So waiting queue is nothing but ready or runnable state. Means the threads are ready. Ready means they are waiting for the CPU. Okay, means all the threads are in the waiting queue. That is nothing but ready or runnable state. Next, from ready or runnable state, the thread will go to the running state. So when it will go to the running state from the ready state, okay, that is nothing but if the thread scheduler allocates the CPU, because in this ready or runnable state, all the threads are in the waiting queue, no? Okay, why they are waiting? Because they want the CPU. That's why all the threads are in the waiting queue. So who will allocate the CPU for the threads which are there in the waiting queue? Thread scheduler. So if the thread scheduler allocates the CPU for any thread, then that thread will go to running state from the ready state. Okay, that is the third point. So this is the third point. If the thread scheduler allocates the CPU, then the thread entered into which state? Running state. Okay, so after getting the CPU, okay, by the thread scheduler, now the thread, okay, that is previously it was in the ready state. Now the thread will go to the running state from the ready state once it got the CPU. So that is the meaning of running state. Okay. Next, from running state, when it will go to the dead state. So if the run method is completed, morning I clearly explained. So we should override the run method of the thread class in our thread definition. That is class my thread extends thread. In that thread definition, we must override the run method. Okay, in that run method, we will write the functionality of that thread. Means whenever run method completes its execution, okay, the thread will go to the dead state. That is from the running state, it will go to the dead state once the run method is completed. So here the last point is, if the run method is completed, then the thread will be entered into the dead state. So this is the life cycle of thread. With these four states, we can explain the life cycle of thread. First, the thread will be in the born state. Next, from the born state, it will go to the ready or runnable state after execution of T dot start statement. Next, from the ready or runnable state, it will go to the running state whenever the thread got the CPU, which is allocated by the thread scheduler. Okay. Next, when it will go to the dead state from running state is once the run method is completed, then the thread will go to the dead state from the running state. So this is, if you see the program and correlate this diagram and the program, then you can easily understand the life cycle of the thread. So this is very, very important for exam point of view. What is the next concept here? After starting a thread, restarting the same thread once again, okay, is not allowed. Otherwise, we will get runtime exception saying illegal thread state exception. So here morning I explained up to these 2 points. No? So for each and every thread, morning I explained one example. No? How do we find 5 tasks using arithmetic operators? Okay, that is, we have discussed a program now, that is multi-threading program for performing all these 5 tasks. There we have created for each task one new thread, and after defining the new thread, we are creating the object for that thread, particular thread. So for each thread, these 2 statements are very, very important. Suppose if you create 5 threads, for each and every thread, these 2 statements are very, very important. Suppose if you want to create 5 threads, write 5 separate classes. Each class represents one thread. Okay. After defining the thread for each of the 5 tasks, then these 2 statements are must for each and every thread. That's why morning I explained, totally you will get 10 statements like this. Because for each thread, these 2 statements are important. Because already explained, first define the thread, after that instantiate the thread, then start the thread. So definition of the thread, then instantiating the thread, then start the thread. So for each thread, these concepts are important. So how do we define a thread is, okay, class myThread extends thread or class myThread implements runnable. So inside that we should write the overriding run method. Inside the overriding run method, we will write the functionality of that thread. That is nothing but definition of the thread. So if you want to do 5 tasks, then create 5 or define 5 threads for each of the 5 tasks, or define 5 threads for 5 tasks. Means 1 thread for 1 task. Like that, first define 5 threads. After that, instantiate each thread using this syntax, and after that start each thread. Like that, for each thread we have to write these 2 statements after defining the thread. So if you define 5 threads using 5 different classes, after that you have to write 5 into 2, 10 statements like this for each thread. Because for each thread we have to, after defining, we have to instantiate and as well as we have to start the thread. Because define, instantiate and start, these 3 are very, very important for any thread. Okay. So after defining the 5 tasks using 5 classes, then for each thread we have to write these 2 statements. This is instantiation of a thread. This is start a thread. Okay, that's like that. We have to write 10 statements. Morning I explained. And now here I will explain one more important point here. So here this is instantiation of the thread. After that we have written t.start. So here start method of the thread class is invoked, and the responsibility of the start method of the thread class is to register our new thread with the thread scheduler, and it will invoke the run method of the thread class. So after this statement or after execution of this statement, our new thread is registered with the thread scheduler. Means new thread is created. Here what I am trying to do is, I am trying to, here I have written the same statement once again. Then what will happen? So I have written again t.start. So what does it mean? What is the meaning of this one? So with this statement, already our thread is registered with the thread scheduler. Then if you write the same statement again, what is the meaning of this one? Already your thread is registered with the thread scheduler. In this statement, what it will do? It cannot do anything. That's why once you first time only it will accept to register your thread with the thread scheduler. After that, if you write t.start method, then it will give you, it is not a syntax error because compiler doesn't know. Syntactically it is correct only, no? t.start correct only. Compiler doesn't know how many times should we write the start method, or how many times should we invoke the start method of the thread class. So the compiler doesn't know all these. It knows only the syntax. So as per the syntax, this is correct, this is correct. That's why it is not a compiler error. You can write any number of times the same statement, but the compiler will not give you any error. But when the JVM will execute this statement first time, okay, so it will using the start method of the thread class, our thread is registered with the thread scheduler. After that, again, this statement is invoked by the JVM. Okay. What it will do? It cannot do anything. It cannot again invoke the start method of the thread class again. Because already your thread is registered with the thread scheduler using the start method of the thread class with this statement. It is enough. So T dot start statement must be written only once for one thread. Suppose if you create object for the second thread, again we can write T1 dot start, T2 dot start, T3 dot start. That is correct only. But here we are creating only one object. With that reference variable, I am invoking start method, means this should be written only once. If you write more than once, so JVM will give you runtime error. This is correct only up to this. So here this is called runtime error. Already you know the name of this runtime errors are called exceptions, no? And the name of the exception at this point of time is illegal thread state exception. Illegal thread state exception. You know this is an unchecked exception, which is the child class of runtime exception. Already explained runtime exception and all its subclasses are unchecked exceptions. Okay. So this is the means T dot start will be written only once. If you write more than once, you will get the runtime error. That is, the name of the exception is illegal thread state exception. We can note down in exception handling this also. This I have not explained in exception handling. This exception I have not explained. So in multi-threading only you will get this exception. So you can write this program for illegal thread state exception. Okay. Next, coming to the next concept. Already morning I explained clearly. There are two ways to define a thread. I will show you. So here, in the first page, I have shown no morning. So define, instantiate, and start a thread. So instantiate and start a thread is, instantiation is nothing but creation of an object for the thread class, and start means to invoke the start method of the thread class. These two are same for all the threads. But if you see this concept define, here we have two ways to define the thread. Okay, understand? Instantiation and start, that these two concepts are same for all the threads. But when you see this part, that is define a new thread. Here we have two cases. What are the two possibilities? Okay, what are the two possibilities? This is there are two ways to define a thread. So what are the two ways? By extending thread class or by implementing runnable interface. So morning I explained how do we define a thread by extending thread class. So you know now already this is class my thread extend thread. In this I will write the code for the overriding run method. This is the new thread definition. If you want 5 threads like this, we have to take 5 classes with the names my thread 1, my thread 2, my thread 3, my thread 4, my thread 5. After that we have to create an object for each thread, and we have to invoke start method of the thread class. These two statements are for one thread. If you create 5 threads, means if you take 5 classes for 5 threads, then we have to write 5 into 2, 10 times like this. Okay, this program is for extending thread class. Okay, so there are two ways to define a thread. First one is by extending thread class, and second one is by implementing runnable interface. So try to understand the first program. This is by extending the thread class. Already explained the predefined class thread. Okay, and this program in depth. Now I will explain by implementing the runnable interface. Only small difference is there. I will explain that difference with one program on runnable interface. So in multi-threading, thread, predefined class thread and predefined interface runnable. These two are very, very important. So thread class and runnable interface, both are there in the java.lang package. So this is the second way of defining a thread by implementing runnable interface. If you take any program in multi-threading, okay, there are only two ways to define a thread, or there are only two ways to create a thread. First one is extends thread, second one is implements runnable. Okay, remember these two. Now runnable interface is present in java.lang package and contains only one method run. You know, no interface consists of, so runnable, we are saying runnable is an interface. And you know the definition of interface. Interface consists of only final variables and abstract methods. Okay, so here in the predefined interface that is runnable, in this we have only one abstract method, that is this one. So public void run, why it is abstract method means it has no body and ends with semicolon. You know runnable is an interface. Runnable is an interface. Interface consists of only final variables and abstract methods. So interfaces consists of 100% abstract methods. But here this is defined by the Sun developers now. Runnable interface is a predefined interface which is there in java.lang package. So how they have defined is interface runnable, okay, open brace, closing brace. In that they have written only one abstract method, that is public void run, means this one. So inside the runnable interface, there is only one abstract method, that is called run. Okay, now understand this one. After that, here thread class, thread is a predefined class now. So the thread class implements runnable. They have taken this structure, okay, between thread class and runnable interface. So here, you know, morning I explained no thread class. So inside the thread class, I have explained two methods. They are start method and run method. So run method inside the thread class is null implementation. Okay, and you know the start method of the thread class. So this is a predefined class and they have taken like this. The relation between these two, that is the relation between the thread class and runnable interface is class, here I will show you, class thread implements runnable. So class thread implements runnable. What does it mean? So inside the runnable interface, we have only one abstract method run. So when this class thread implements runnable means this inside this class we have to provide implementation for this abstract method. That's why inside the thread class they have provided null implementation to run method. Because when this class thread implements runnable means runnable interface consists of only one abstract method, that is called run. So when this class thread implements runnable means, so inside this class thread we must implement this run method of this runnable interface. That's why inside the thread class they have implemented run method of the runnable interface, but that too they have taken null implementation. Null implementation also correct, because body is there, no? Understood carefully. Inside runnable interface there is only one abstract method. So here they have taken class thread implements runnable, means inside the thread class this run method must be implemented. That's why inside class thread implements runnable, inside the thread class they have taken run method with null implementation, and in addition to the run method they have taken start method. Like that there may be any number of methods in the thread class, but these two methods are important, that is run method with null implementation and start method inside the thread class. And here class thread implements runnable, okay, means interface runnable. In that runnable interface we have only one method, that is abstract method, which is called run method. That's why inside the thread class, run method is implemented, but they have taken only null implementation. But it is also correct. So the relation between thread class and runnable interface is class thread implements runnable. Okay. Next, after that, we can write the programs in two ways. No, that is, first program is class my thread extends thread. Morning I explained. No, class my thread extends thread. That is one way of defining the thread. What is the another way of defining the thread? Suppose if you take class my thread extends thread, it means class extends thread, in turn class thread implements runnable. This is the entire structure you will get in the first approach. First approach is nothing but defining a thread using thread class. Means you will get this. Okay, this structure. Next, what is the second approach? The thread, to define a thread, we can use implementing runnable interface. Means defining a thread by implementing runnable interface. Now, this is the second approach. What is this? This is the name of the class. So, class myRunnable directly implements runnable, but here indirectly implements runnable. See, so my class myThread extends thread. Again, class thread implements runnable. So the meaning of this is indirectly this class myThread implements runnable, but here in the second approach, directly our class implements runnable interface. Anyway, whether you take first approach or second approach, either directly or indirectly, that class implements runnable interface. So that is the importance of runnable interface in multi-threading. Understand carefully. Here there are two ways to define the thread. So in the first way, okay, in the first approach, indirectly the class myThread is implementing runnable interface, means through thread class. But here in the second approach, our class myRunnable directly implements runnable interface. Directly implements runnable interface means runnable interface is having one abstract method that is run method. So if when myRunnable class directly implements runnable means this inside this myRunnable class, we should implement this run method. That is abstract method of runnable interface. But if you take the first approach, myThread extends thread, in turn thread implements runnable. No, so this is directly implementing runnable interface. No, that's why this class has to provide the implementation for the abstract method, that is run method of the runnable interface. So inside the thread class, we must provide the implementation for run method. That's why they have provided null implementation for run method. After that, in our class, that is class myThread extends thread, we are writing the overriding run method of this thread class. Because in the thread class, run method is implemented, no, that is null implementation, no. So in our class, we are overriding that run method of the thread class. So this is indirectly we are implementing runnable interface in the first case. But in the second case, this class myRunnable directly implements runnable interface. Directly implements runnable interface means because we know runnable interface consists of only one abstract method, that is run method. So when this class directly implements runnable interface means this class has to provide the implementation to the run method of runnable interface. That is the only difference. Here thread class is providing the implementation for run method of the runnable interface, but here myRunnable class is providing the implementation for the run method of the runnable interface. So understand this structure and this structure. This is directly implementing, this is indirectly implement, because in this case, inside the thread class, we are giving the implementation to the run method of the runnable interface. But if you take this scenario, here this class must provide the implementation for the run method of the runnable interface. Now already I explained this in depth. Now I will take the second approach. Now here you can easily understand now this. Now in the same way we will write, only few differences are there. So what is the first program here? There in morning I explained. There class myThread extends thread. But here class myRunnable is the name of the class only. It is a user defined name. You can take as you like. Okay. So class myRunnable, okay, implements runnable. In the first program, it is extends thread. Now in this case, it is implements runnable. Only these are the two ways to define a new thread. If you understand this, you can understand the remaining programs. Okay, there are two ways to define the thread. Either class myThread extends thread or class myRunnable implements runnable. You know, runnable is an interface which is having one abstract method called run method. Now, when this class implements runnable interface, what does it mean? So this class myRunnable has to provide the implementation for the abstract method, that is run method of the runnable interface. That's why they have provided the implementation for run method, that is abstract method of the runnable interface. So here this is the implementation of run method. Okay, this is must. Okay, that's why, because here class myRunnable implements runnable. Understand carefully. Runnable interface consists of only one abstract method, that is run method. So when a class implements runnable interface, means that class has to provide the implementation for the abstract method of this runnable interface. That's why here this class myRunnable is providing the implementation for the run method of the runnable interface. Run method is an abstract method in the runnable interface. That's why this class is providing the implementation for the abstract method, that is run method of the runnable interface. Now here this is the implementation of the run method. No? So inside the run method, what I am writing, same. I am writing the job of the thread. Here one more brace is there, closing brace. This is class open, this is class close. This is run open, run close. This is for open, for close. Okay. Oh, so put one more brace. This entire thing is nothing but defining the thread. If you see here too, defining a thread. This is the second way of defining the thread. That is class myRunnable implements runnable. So inside that I am giving the implementation to the abstract method, that is the run method of the runnable interface. That's why here how do we implement the run method is, I am taking the same public void run. Inside this run method I am writing the, or I am giving the functionality for this thread. This entire thing is called defining a new thread. Okay, same concept. There we have written overriding run method in the first approach, but here we are implementing the abstract method of the runnable interface. This is the implementation of the run method, which is there in the runnable interface. In runnable interface, run method is called an abstract method. When a class implements runnable interface, means it has to provide the implementation to the run method of the runnable interface. So this is the one difference. If you take the first approach, class myThread extends thread means, okay, so inside that we are writing the overriding run method of the thread class, because in the thread class run method is already implemented, which is having null implementation. So there in the first approach we are calling it as overriding run method of thread class, but here we are implementing the run method. So that is the first difference between these two approaches. Okay, next. So anyway, we should write the run method to write the functionality of the thread, whether it is the first approach or second approach. Finally, compulsory we should write run method, and inside the run method only we should write the functionality of that particular thread. So this is nothing but in the second approach to define a new thread. Next, after that, one more difference is, see, class thread demo. Okay, we have to take one more class now to write the main method. This is the thread definition using the second approach. That is implements runnable. Next, after that, like in the first program, here also we will take one more class. Inside that, I will take the main method. So inside the main method, we have to create an object for this, no? myRunnable class. So first I will create an object for myRunnable class. That's why myRunnable r is equal to new myRunnable. It is correct only. But can you write r dot start here? Understand carefully. So in multi-threading, whether it is first approach or second approach, finally our aim is to invoke the start method of the thread class. So start method of the thread class is the heart of the multi-threaded programs, remember. Suppose here we are creating myRunnable class interface, myRunnable class object using this syntax, myRunnable r is equal to new myRunnable. Now after this, can you write r dot start? Like in the first program. In the first program, what we have written? My thread t is equal to new my thread. After that, t dot start we have written. But there, my thread is the subclass of the thread class. So by creating the child class subclass objects, we can access both the superclass members as well as subclass members. Like that, using t dot start method, we are invoking the start method of the thread class in the first program. But understand carefully. Now can you write r dot start? Suppose if you write r dot start here, what will happen? Okay, if we write r dot start here, it will go to the myRunnable and it will check for the start method. But start method is not there, no? That's why don't write r dot start here. Why? Because start method is not there in the myRunnable class. That's why if you write r dot start, you will get compiler error. Next, finally, what is our aim in multi-threading program? Whether we use first approach or second approach, okay? Our focus is how do we invoke the start method of the thread class? That is compulsory. Only with the start method of the thread class only, our thread is registered with the thread scheduler. Without invoking the start method of the thread class, no new thread is created. It is like normal class. But in multi-threading, we want thread, no? When we create multiple threads, what is the advantage is performance-wise, it is better. Okay? Now, so here we can't write r dot start. Next, here, if anyway, my aim is to invoke the start method of the thread class, no? That's why I am creating the thread class object directly by taking this runnable interface as parameter to this thread constructor. Okay, with this t, I can access start method. Next, t dot start. That's why these two statements are compulsory in the second approach. Directly, if you create object for myRunnable class, and if you write r dot start, there is no use. Because class myRunnable implements runnable. That's why thread class start method will not be invoked if you write r dot start. So the solution for that is, I will create object for that thread class. I will create object for thread class, and here this is constructor, you know, no? So in use this with this here, this is taking one parameter. I will take the myRunnable interface reference variable as the parameter of this thread constructor. Again, I will explain the constructors of thread class. Because for predefined classes, we should know the predefined constructors only. Okay. So the first here we are creating the thread class object by giving the parameter for this constructor as the runnable interface reference variable. Like that, I am linking these two. So after creation of this thread class object, we can call start method, or we can invoke the start method of the thread class. So this is thread class object, no? That's why t dot start. Here you may get one doubt. Why this r? Why we should take r as the parameter for this thread constructor? It is must. Why? Because if you don't take this r, how do we execute the run method of this myRunnable interface? Because this is the new thread, and inside that the functionality of this thread is written in the run method of this myRunnable interface, no? Suppose if you don't write r here, Suppose if you write only thread t is equal to new thread, okay, no arguments. Then if you write t dot start, what will happen? It will go to the thread class start method and it will execute and it will register our thread with the thread scheduler. After that, it will invoke the run method of the same class with null implementation. So run method is there in the thread class with null implementation. So what is the purpose if run method of the thread class is executed? No use, no, null implementation means nothing will happen. That's why here we must invoke or we must execute the run method of the myRunnable class. Inside the run method of the myRunnable class, I have written the functionality of that thread. That's why this has to be executed or this must be executed. This run method must be executed. So how do we execute this run method is by taking this constructor thread of R. This constructor is taking one parameter and this parameter is nothing but thread class reference, this myRunnable class reference variable. Means we are linking these two. Otherwise, if you won't write R here, okay, then what will happen? T dot start means it will go to the thread class start method and it will register our thread with the thread scheduler, okay. After that, it will invoke the run method of the thread class. But run method of the thread class has null implementation. That's why this code will not be executed. So how do we execute this run method of this myRunnable interface is by taking in the thread class constructor by taking R as the parameter. This is nothing but thread class constructor. Okay, this is the thread class constructor. It is taking one parameter and that parameter is nothing but our myRunnable. Okay, myRunnable class object or reference variable. So this is thread, okay, creation of thread class object. So with this object, I can invoke the start method because it is a thread class object only, no. So with the thread class object, I can access all the members of the thread class only, no. In the first, to understand the difference between the first program and the second program, only here there is a difference. Here we are writing two statements. In the first program, we are writing only one statement. That is, we are creating only child class object, that is subclass object. That is, instead of these two statements in the first program, it is myThread T1 is equal to new myThread. MyThread is the subclass now, because using this subclass object, I can access both superclass members and subclass members. Like that, I am accessing the start method of the thread class. Anyway, finally, our aim is to invoke the start method of the thread class. It is must, whether it is first approach or second approach. So here through the child class object, we are accessing the start method of the thread class. But here directly using the thread class object. Okay, here it is through child class object, no. That is myThread is the subclass of thread, no, in the first program. That's why by creating the myThread class object, that is by creating the subclass object, we are accessing the members of both superclass, that is thread class and subclass. But here in this second approach, our class is not extending thread class. Our class is implementing runnable interface. Then by creating the object for this one, we can't access the start method of the thread class. That's why here what I am doing is, in the first approach, we are creating the object for subclass, that is myThread. Instead of that, in the second approach, I am creating a thread class object like this. Directly I am taking the superclass thread. Thread is the superclass in the first program. So here in this second approach, directly I am creating thread class object to access the start method of the thread class. But here I am taking the parameterized constructor of thread class, which is taking only one parameter, and that parameter is this myRunnable class reference variable. So by creating thread class object like this in the second approach, we are accessing the start method of the thread class. That's it. In the first approach, by creating the subclass, that is myThread class object, we are accessing the start method of the thread class. But whereas in the second approach, by creating the thread class object directly by taking runnable interface object as parameter, okay, we are creating the thread class object like this. With this T, I am invoking the start method of the thread class. That's why T dot is there actually here. T dot start means it is invoking the start method of the thread class. So after T dot start, what will happen? Our new thread is registered with the thread scheduler. Okay, that is the first thing, and it will invoke the run method of the same class. Okay, now here when you write T dot start method, so after this statement, there are two threads which are there in the waiting queue. What are the two threads? Main thread and child thread. This is the main thread functionality. Main is also always one thread, no? This is the main thread functionality, and this is the child thread functionality. If we execute this program or the first program, both are the same. But there are two approaches to define a thread. One is extends thread, another one is implementing runnable interface. But only the second difference is here. Here we are writing two statements. There in the first program or in the first approach, we are writing only one statement. That is, we are creating the child class object there. But here we are creating first my runnable interface class object. After that, we are sending that reference variable as parameter to the thread class constructor. This is nothing but thread. We are creating an object directly for the thread class. Here we are creating an object directly for the thread class. So with this thread class object, I can access the start method of the thread class with T dot start. Finally, these two threads are executing parallelly. This is the functionality of the child thread, and this is the functionality of the main thread. So when two threads are executing parallelly, okay, simultaneously, so we can't expect the exact output. Okay, in the first program I explained the output, no? Like that here also, okay, we can't expect the exact output because here this is the child thread and this is the main thread which are executing parallelly. So this is the second way to write the multi-threaded programs. These cases you can study on your own. Please go through these cases. After that, next question is, now we have two approaches. So which approach is recommended to define a thread? This is important. So among the two ways of defining a thread, implements runnable is always recommended. Here we have two approaches. First one is extends thread. Second one is implements runnable. So out of these two approaches, which one is better means always implements runnable. That is the second approach is the better one. Why? Because you can see first approach is what? Extends thread, no? What is the drawback? I will explain here. First we will go to the first program. This is the first program. Defining a thread by extending thread class. Try to understand today these two ways of defining a thread. These two are very, very important. Okay. Now this is the first approach, no? That is class myThread extends thread. Next second is class myRunnable implements runnable. So out of these two approaches, which one is better? That is the question now. So the answer for that is implements runnable is better. Why? Because you know Java does not support multiple inheritance. Suppose if you take the first approach, that is class myThread extends thread. Means can you extend one more class here? Can you write one more class here? Means inheritance is not possible here when you write extends thread. Because in Java, one class can extend only one thread. One class cannot extend more than one thread. Means Java does not support multiple inheritance. Okay, suppose when you take the first approach like this, class my thread extends thread means you can't extend any other class. Understood? Suppose if this class my thread wants to extend, let us take test. Class test is there. Okay, I have defined one class test. And next after that I want to use inheritance for this class. That is class my thread extends thread. Can you write extends thread? If you use this approach? No. Why? Because in Java one class can extend only one class. Suppose if you want to write again extends test, how do we write? Class my thread extends thread comma test. Because this class wants to extend one more class test. Then in that case, already it extends thread, no? In the first approach. Again, it wants to extend one more class, that is test. So in that case, how to write that one? Class my thread extends thread, comma test. But Java does not support this syntax. Because one class cannot extend more than one class. You can't write extends thread, comma test. So that is the reason this first approach is not better. Suppose if you take the second approach, it is possible. Means that class can extend test class. Why I will show you the second approach. That's why out of these two approaches, better one is the second one. This is the second approach, no? See, we will see the program. Now here I have class test. I have defined one class with name test. So this class wants to extend that class. So in the second approach, it is possible. Why? Because here it is not extending any class, no? It is implementing runnable interface, no? That's why class my runnable extends thread. Here I will write in between these two. So extends thread. Next implements runnable. It is correct only, no? That's why always the second approach is better, because here in the second approach, inheritance of one more class is also possible. But if you take the first approach, already that class my thread extends thread, no? Already it is extending one class, so it cannot extend more than one class. That's why that the inheritance is not possible in the first approach. But if you take the second approach, I can take inheritance. That's why how to write that one? Class my runnable extends thread extends test implements runnable. Means it is extending our test class as well as it is implementing runnable interface. So implements runnable is nothing but creation of a thread, no? Creation of a new thread is possible, no? Even though it is extending thread class, we are creating a thread. But if you take the first approach, class my thread extends thread. Suppose if this class wants to extend test class, you can't use extends thread, no? We can write only class my thread extends test. Then thread concept is missed, no? We are missing the thread concept. That's why this second approach is better. Means in this case we can write class my runnable extends test implements runnable. Here we are getting the concept of thread as well as it is extending the properties of another class test. So that's why the second approach is better when compared to the first approach. This is interview question. Which one is better? Why? You have to justify with the answer. So among the two ways of defining a thread, implements runnable is always recommended to use. In the first approach, to define a thread, our class should extend thread class. Here it is missing. So in the first approach, to define a thread, our class must extend thread class. Okay. There is no chance of extending any other parallelly, because multiple inheritance is not possible. Hence, we are missing the key benefit of OOPS inheritance. That's why here note down thread. Okay, when our class is extending thread class, it cannot extend any other class. That's why we are missing the inheritance concept in the first approach. But if you take the second approach, we are getting the thread concept as well as we can inherit one more class, or we can extend one more class. So, but in the second approach, we can extend any other class. Here we can't extend any other class now, because already it extends thread class. That's why we can't extend, it can't extend any other class. That's why we are missing inheritance. But in the second approach, we are not missing inheritance, because in the second approach, it is implementing runnable interface. So this here in the second approach, we can extend any other class in addition to implementing runnable interface. Okay, so with this, these two ways are completed. So try to understand these two programs, very, very important. Once you understand these two programs, then only you can understand the remaining part of multi-threading. Tomorrow we will discuss constructors of thread class and how do we set and get the names for threads and set priorities also, not set thread priorities also we will discuss.